This is section 7.6, number 32. So it's another trig verification. I'm allowed to change either the right-hand side or the left-hand side of the problem. I need to show each step as I go. So basically one change, new line. One change, new line, until you have both sides equal to each other. So I'm looking at this. Typically, it's easier to simplify something than to try to make something more complicated. So I think I'm going to try to simplify this side of the equation, okay? I can't break up sum or a difference in a denominator. I would have to have common denominators to do that. So there's not really much I can do here. And same kind of thing here. I could write this as 1 over sine of theta and cosine of theta over sine of theta with a common denominator. But again, that doesn't really seem to link into this as well either. So the only other thing here that jumps out at me, I want to write this in a drastically different form because I don't see anything here that's doing anything for me. Remember when you add two fractions, if I add like a third and a fifth or something like that, you need a common denominator. You can always multiply the two values together to get a common denominator. So for example, 15 could be a common denominator here. So I'm going to do that. I'm going to add these with a common denominator. My common denominator will be the product of both of these. Okay, so I'll have to multiply this by sine of theta, and that's going to be multiplied by sine of theta on top. And then this one over here, I'm going to have to multiply, I'll move this over just a little bit. I'm going to multiply by 1 minus cosine of theta. And then I'll also multiply by that on the top, and we'll see what happens here. So again, this may not work. A lot of these problems, you try 2 or 3 things and eventually something works, but you're just trying to put it in a drastically different form, and I thought, hey, if I add those fractions, that'll be a drastically different form. So let's see what happens. So our common denominator here on the bottom is going to end up being sine of 1 minus cosine of theta, okay? And on top, we've got a sine squared of theta, okay? This whole thing here is getting multiplied by this whole thing here, so that's going to be plus 1 times 1 is 1. We get a minus cosine theta, we get another minus cosine theta, so it's minus 2 cosine of theta. And then we're going to get a plus cosine squared of theta, okay? And this whole thing is supposed to be equal to 2 cosecant of theta, okay? So I see something jumping out at me right here. Sine squared plus cosine squared, of course, is equal to 1, okay? And so I can replace these two things with a 1, okay? So that would be a 1 plus 1 minus 2 cosine of theta. 1 plus 1 is 2. So 2 minus 2 cosine of theta over sine of theta, sorry, it should be sine of theta, times 1 minus cosine of theta. And this whole thing needs to be equal to 2 cosecant of theta. Okay? So we're not done yet. But I noticed something. This looks a little bit like this, except this has been multiplied by 2. So I'm going to factor out the 2 here and write that as 2 times the quantity 1 minus cosine of theta. And now you can see in my fraction here, I can divide a 1 minus cosine of theta out of the top, and I can divide it out of the bottom. Of course, it goes into itself once each time. So now I have 2 sine of theta is equal to 2 cosecant of theta. Of course, sine is just the reciprocal of cosecant. So you could move that up to the top as a cosecant, and you'll get 2 cosecant of theta is equal to 2 cosecant of theta. It's a really tough problem. Good stuff.